Is there any topic that you remember that, you were studying in physics and it just made you go like, wow, like I really want to pursue this?
Optics.
Optics.
It's always optics.
Hmm.
So the experiments with light, interferometers, using lasers for the first time, right? It's always optics which intrigued me.
So was it just like the naturality of it, like oh, it's everywhere, so nice to have it deduced, or what was it about optics? Was there anything in specific, or was it just like the field itself that just intrigued you in general?
If you just think about it, it looks so simple, right? Like, so light travels in straight line, right? Light doesn't interact with another beam which is going unless you make special conditions.
Mm-hmm.
But then there's so much interesting you can do, right? Not just with light itself, but how light interacts with matter. Right. So
Hmm.
and when you go to lower dimensions, like so for example, you cannot measure how two electrons interact with each other, how electrons interact with, say, for example, the lattice vibrations, which are the phonons. Right. These time scales are beyond the or limits of the present day electronics, but then you can use optical spectroscopies, right, to probe these at say sub-picosecond to few femtosecond level time scales, right? So light offers like so much to study, not just how properties of light itself, but how light interacts with matter and what we can achieve with it.
Right. I also find optics so interesting as well because if you think about not that long ago where we didn't have all this like modern technology, it's something that was really mysterious and hard to actually study. And I always like to think about the times where um, scientists back in the day would try to make assumptions about light. And, at the time, they couldn't really prove themselves right or wrong. They just had to kind of take a guess and then try to go from there.
Yeah, optics was very different, I guess, right? In the older ages, even I mean before someone like Einstein and with special relativity and all, I'm assuming the world of optics or anything really would be quite different. So so here we are. You have stayed on these extra 2 years, and you've now got into or kind of like physics a little bit more. So was this like in your undergrad that you stayed on, and then you just continued on to like a PhD after, or how did that process work back then?
Right. So I went on to do my master's in Central University, Hyderabad, which was kind of mecca for optics at the time with really good teachers who are in the top in the world in quantum optics, for example. Right. So, for example, Professor Girish Agarwal and right. So they're good names, good motivating teachers. Like so, I went on to do my master's at University of Hyderabad, also called Central University of Hyderabad. Right. And then I moved to TAFR to work on spectroscopy, optical spectroscopy, especially these ultra-fast dynamics, like so how carriers interact in semiconductors.
Ah,
Right.
that's very
And
cool. Yeah, sorry, continue.
mm, so yeah, that was the journey, right? Yes.
That was a journey. So again, we see itself that optics has clearly evolved so much in like the last, again, since special relativity. I'm just going to keep that as like a pivot point. Since then, I'm assuming
Yeah.
like it has evolved quite a lot. And you've now researched at the TIFR, which to our listeners, the Tata Institute for Fundamental Research in Mumbai, India.
Yeah.
And now you are also at the National Physical Laboratory in New Delhi. And you've also, I'm assuming, been
Yes.
working at these both spots for some amount of time, considerable amount of time, taking that you went to TIFR right after you graduated. So I guess my
Right.
question is, if optics changed so much from special relativity, how much did it change since when you've been in it? How have you
Right.
advanced with the technology, or how has the technology advanced with you?
Right. So now we more look at, I mean, the classical optics is still interesting, right? So what we're talking about the old times, like so the lens maker equations that, I mean, these are all fundamentals which we need to if I want to develop a good instrument, optical instrument, of course, I need to have strong basics in my classical optics, right? If I want to look at applications of optics, where the photonics area has evolved, right? So it's completely application of these, the basics has come out considerably well, like the fiber optics and right, we're also talking about single photon communication and all these things, right? So it has evolved quite a bit, moving from say millions, sending millions of photons over fiber or free space communication to we're talking about sending single photons, detecting single photons, or generating single photons, right? How to generate them and how they interact with matter, right? So it's considerable progress which has happened over the last, I don't know, 70, 80 years at least, because it's also linked to semiconductor development. And now we're trying to look at, people talk about if we can replace electrons with photons.
Hmm.
Right?
Right.
So, but we're still off, but we're inching closer.